Hello everybody, I welcome you all to the Project Phase 2 presentation on the topic Smart Food and Supply Chain Model. We three, myself Abhishek Ranjan along with Aditya Kumar Sinha and Sarish Bhamre have completed this project with cooperation with a company named Okpro Private Solutions Limited. We would also like to thank our college and Professor Dr. Varsha Degaonkar for continuous support and upliftment throughout this process. So, this gives us the basic outline of our project and various topics that we have discussed in the PPT. Right, starting off right from the introduction through proposed methodology, results, conclusion, and ending off with references. So, let's start off with the introduction. So, our project mainly combines two major fields, that is IoT, Internet of Things, or SCM, or we call it supply chain management. Similarly, a small model is created with integration of logistics, food, services, and analytics. This project will provide competent method for recording real-time readings and will help people who are a part of this chain. Also, we have found the optimal way and efficient way for how a SCM company should work. This, in turn, will reduce the cost of the goods. So, as we move on to the literature survey, we went through a lot of research paper and research work that had been done by previously known researchers. Like we have mentioned the four new papers over here. The first one, Internet Things, a paradigm shift of future internet application. The methodology used was completely on IoT, whereas it had great accurate results in terms of the received data. But the only demerit that was found was it was only working with one sensor, which we felt could have been improved by using multiple sensors so that our system could be big enough, considering we have many different products around. Similarly, the second paper, Internet Things for Enterprise Solution, was a completely on analytics part where great visualization was done, and we could see and take into our consideration how can we use the data captured and analyze it well. Similarly, the paper 3, the supply chain operations, was a completely thesis paper where we understood what supply chain is all about and where we could use our IoT product to improve it. Finally, paper number 4, strategic sourcing, a systematic approach to supplier evaluation, selection and development. It was a paper where SCM was integrated with AI, and we understood a lot of positions where IoT also can be replaced for with AI. So a proposed definition has mainly three key features. First, digital require connectivity is a very must in this project, whereas the nature of the connectivity is proactive, allowing data to be stored and analyzed. Similarly, IoT will be facilitating planning, controlling, coordination of the supply chain products. Moving on to the gap identification, there are few problems that have been listed in the current system. Like supply chains are under an ever-changing environment. Environment is changing because of many factors, right off from the delivery to the destination and everything. Moreover, the customers in the market are now more and more demanding on the basis of products of quantity and quality. Similarly, products complexity is also increasing due to the rapid changes in technology. So the solutions that we came up were IoT has a major impact on the SCM supply chain due to its ability of integration with various processes. IoT takes supply chain communication to another level. Moreover, the possibility of human to things communication and autonomous coordination also improves. IoT will help us to cope up with various SCM challenges and also will allow the reduction in any operation. Now, I request other members to continue.
Now I'll be talking about the problem statement and the objective. The problem statement of our project is to design a model for smart chain apply management by using the IoT and visualizing and analyzing the product by reducing its intermediate costs and making the whole setup smart and cost efficient. Talking about the objective of this project, the basic objective of this project are to build the IoT framework for food monitoring system. Then later on we'll be monitoring the product by the visualizing and analyzing the data from the respective system with light data fit on temperature, moisture and other parameters. Now I'm talking about the proposed methodology. The basic purpose methodology on this project is to find the cost effective fridge for the supplied food management system and supply chain. The system and our system will be capable of sensing as well as monitoring its content. The sensors of the data will always be active in detecting mode. And design aim and our aim is to design its aim which is easy to use and economical to the user, and he can easily get the live data feed from the product what he wants to visualize and his analysis. And the whole system is governed by the microcontroller where the sensor act as an input, and the whole data transmission between the sensor and the at the other end is being done by the Wi-Fi transmission and wireless sensor by using IoT. Now Saris Bhamre will talk you about the proposed requirement analysis.
Hello, as Abhishek and Aditya had discussed you with the problem statement and objectives of this project, I would like to discuss the requirement analysis of this project. So this project of ours requires hardware part and the software part. So the main hardware components which we have used are mainly the microcontrollers and sensors. Here the microcontroller used is Node MCU and the sensors used are BMP180 for the air pressure sensor, MQ135 as the gas sensor, and DS1820 as the air temperature sensor. So these sensors are and microcontrollers are used with various basic components like resistors and capacitors to make a hardware unit. Moving on to the next require analysis, that is the software part. So here we have used various softwares for our project. So the main softwares used are the Tableau, which is used for data processing and data virtualization. Also for doing that we have used data Excel as the data storage software. Also we have used web host as the website development software, and for the circuit simulation we have used Circuit.io, and for the code testing we have used Arduino. Also the video which is made is being done by the Filmora technology. So now moving on to the impact analysis of this project. So the impact analysis mainly includes the positive impact and the negative impact, which would be on the society and the environment. So here the main positive impact on the society would be the data captured would be used for great conclusions. Also we are contributing in the Smart India City program by making the product digital. Also reducing the intermediate cost of the product and all the services. So the negative impact of this project on the society would be the privacy concerns and privacy breach and loss of the jobs due to its smart way of using. So now the impact on this environment would be that the reduction of food wastage would be reduced. Also the less utilization of farming efforts would be reduced, decrease in the environmental pollution, and also maximizing the production to utilization ratio. So the negative impact of this project on the environment would be the increase in energy consumption, and also the more carbon footprints would be increased. So now moving on to the ethical part, practices which should be followed by the professionals for doing any project would be the protection of the privacy, protection of the data security and data usability, also the data user experience of the consumer, and also the trust and safety of the consumer. This all practice should be regulated and should be monitored wisely. Also the IoT devices should also the regulations followed by the IoT should be the devices which are connected for this IoT purpose, and also the network and their security should be also regulated, and also the data of the consumer should be regulated daily.
So now coming on to the system implementation part of it. As you can see on the screen beside, we have made a flow chart or flow diagram to explain you how our system works. So as we switch on to the system, the multiple sensors then start working, and then they transmit the data that they have been capturing and send it across to our IoT platform. This reading of data happens every second, which we plan of changing accordingly whenever needed. When the data is sent onto the IoT platform then transmits that to our database, local database, where we store the data. Moreover, post we have all this data set alongside us, we then move into the analytical part and the cleaning part of the data. Cleaning part is very important for us because there might be many irregular data entries, or there might be data which is very irrelevant to us, which might cause different types of problem in terms of averaging out the values and different things. So it is very important for us to remove the irrelevant data from the data set and then find out the proper data which can be then used for analytical structures. This keeps on going and going. So the sensor data which we read can be the delay can be changed from time to time. As of now, we are using every second, so that every second we get different data. As because we are part of the training, we're still in the testing and the training part of it. We need to understand the different range at which it works. So now coming on to the most important part, that is results. So we start off with the first figure that you can see. We tried to implement our product inside a retail store where we could find multiple refrigerating options, and with each refrigerator having different use, like one could store meat, one could store aerated drinks, one could store other cold storage products. So that's the basic layout that we thought of putting inside our product inside a retail store. Whereas in figure 7 you can see across how we tried to connect sensors across with various microcontroller and then connecting it to one cloud storage. So this was basically done considering that if we just connect multiple sensors to one ESP or one microcontroller, that could create that would give lots of load on one node MCU itself. So it's better if we create multiple systems where we could connect one sensor with one on each microcontroller, giving better outputs and having a better efficiency. Similarly, we received a lots of data, and that too which wasn't cleaned. So it was important for us to clean the data very itself. So in figure 9 you can see the data dump, how it looked. We used to get temperatures in the form of degrees Celsius, and it was important for us to extract the right temperature first of all and then clean it. Similarly, in the figure 8 down you can see the various data cleaned in terms of we had 3 fridges and 3 different sensors, and each one had different limit set. So this is how the data was cleaned and then used later on to visualize it. So here, first of all, in figure 10, some basic mathematical statistics were found out, like number of data set. The first column shows how many data rows we had. Here we were calculating or getting data at an interval of 5 minutes. Similarly, we had different products that we had targeted down in each fridge and with different price ranges. Similarly, we had the minimum and the maximum value observed with its count, average value and standard deviation for each of the product. Similarly, on the left you can see the two dashboards, that is for fridge 2 and fridge 3. This dashboarding was done on Tableau software, whereas you can see we have the first table shows the count of how many data we see for each temperature, whereas other 3 graphs show the temperature variation through the period of the 9 days that we observed. Similarly, the first photo on the top, you can see the web page that we have developed where we'll be putting our solutions and broadcasting the analyzed data. Whereas bottom, you can see how the data is being shown on the website, where you can use filters and different to segregate a particular data. Now, moving on to the conclusions.
Now, as I conclude about our project, the basic conclusion of our project is to find out the real-time issues related for the food logistics using IoT and is monitoring temperature trends with other various movements and its product done. And we have done implementation of IoT with HCM in food logistics system, and data visualization is done to make make a closed loop system which will be observe the effect of external temperature of the system, and it will give ease and make easy to find the uh, logistic part in food chain supply management.
So now discussing the future scope of this product on the society and the environment would be development in the food supply chain in logistics of food and many other things. Also updating and upgrading the system as per the requirement of the consumer. Also integrating many other sensors and also giving modification to this product. Also there would be an improvement in the data security and the data usability of the consumer. Also it would be energy efficient, and the user experience and usability would be much more improved. Also we would like to work on the predictive analytics of this product in near future.